All right, so today's lesson is lesson 1.2. We're going to use segments and congruency. Sorry, my Y got cut off there. I suggest for you to copy down these definitions that you pause the video because I don't know. I want to make sure that you're, all working at your own pace. What I'm going to add to the definitions, if you're interested, is notation. Okay, so and the little I'll highlight some things. So a postulate is really a rule accepted without proof, okay? Also known as an axiom. That is a postulate. Distance. So when we talk about distance, like often that makes me think of absolute value, right? Remember, absolute value is like a number that lies between two bars. The absolute value of +7 is 7. The absolute value of -7 is 7. Absolute value is the measure of distance on a number line from 0. So, refresher. The length of a segment. So the notation, let's say I have a segment AB here. The length is just the two end points, okay? So when I measure from A to B, then AB, I'm just going to write some ambiguous number, equals 7 inches. We'll just say I measured it in inches. But your homework, I think, is incriminating. Make sure you're using the right side on your ruler, okay? So, but just this two letters here together, that's the notation for length. That's telling me that I'm asking for a measurement, or I'm telling you a measurement, or something like that. All right, congruency statement. Here's something else that is, kind of crazy, right? If I had, let's say I had another segment called CD, and it was also 7 inches long, these two segments would be congruent, right? AB is congruent to CD. So I would write that just like this. The segment AB, segment has a bar over top, is congruent. So the symbol for congruent is an equal sign with a little swoopy. It probably has a really fancy name, but I like swoopy. That's what I call it. All right, so the segment AB is congruent to the segment CD. Write it like that. We also know, since I measured them, hypothetically, I'm doing air quotes, in length, I can say that AB, the length of AB, is equal to the length of CD. Because 7 equals 7. Huh? That's pretty fancy. All right, so if you're not finished copying down the definitions, pause and finish. But I'm going to keep moving on. Because there are definitions on tests, guys, and I don't always provide a word bank, so it's really important we understand the vocabulary in geometry, okay? So I know in this postulate 1, the ruler postulate, that do not have those numbers on there. So take a minute and copy this down, okay? And then we're going to talk about what this means, right? So the distance between points A and B, written as AB, right, is the absolute value of the difference between the coordinates, okay? So if I plug in the numbers here for x2, that's going to be my B, so I'm going to plug in 13 here, and I'm going to take away x1, which is A, 4. 13 minus 4 is 9. If I decided that x2 was actually A, and I had 4 minus 13, right? Remember, this is absolute value. It's a measure of distance. 4 minus 13 is -9, but the absolute value of -9 is +9. It's the same, okay? So this is the really important thing, okay? These letters, AB, is called the length of the segment, okay? Make sure you know that. Sorry, that's all right, let's talk some more. Again, if I'm moving too fast, pause it, rewind, watch it. Here we go. Rule it. Just kidding. Postulate 2, segment addition postulate, okay? So I'm going to give you the numbers, all right? I'm going to say that this is point A, this is point B, and this is point C. I'm going to say that here between A and B is 8 units, and between B and C is 4 units. Well, if AB is 8 and BC is 4, 8 plus 4, that equals 12. That equals the whole length of the entire segment, right? Hence the term segment addition. Oops, I'm on the wrong words. Oh, I tripped myself up. Segment addition. Boom, done, love it, okay? So when you're using segment addition, right, let's read this. If AB plus BC equals AC, then point B is between A and C, right? It's in the middle somewhere. All right, let's do some graphing. It's probably been a minute since you did some graphing, okay? So you have this beautiful coordinate plane on your paper. First, I'm going to plot JK. I'm going to plot JK in red. Okay? J is negative 3, 4. J is negative 3, 4, right? We would start at the origin. We go left or right first, then we go up or down. That's how ordered pairs work, right? This is the x-axis. This is the y-axis. So negative 3, positive 4 is right here. That is point J. Then we have K, which is 2, 4. That's the 4. That's K. I'm going to connect those. Lovely. Okay? Now I'm going to put LM in blue. And if you want to use colored pencils, you can. I have some in my room out. They're next to the calculators. Or just use your pencil. Totally fine. All right, so L is 1, 3. And M is 1, negative 2. I'm going to connect those 2 points. Okay, it says, then determine whether JK and LM are congruent. So only, I'm going to stress it, I'm going to write it down, only when we have vertical or horizontal lines can we just count units. We can count units. Okay, we don't have to do any crazy formula. It's coming, but no, we don't have to do that just yet, all right? All right, so let's check out JK. We can count the units, right? 1, 2, 3, 4, 5. It is 5 units long. Let's check out LM. 1, 2, 3, 4, 5. Hey! It's also 5 units long. So, yes, we can totally say that JK and LM are congruent. We can write it multiple ways. JK, the segment, is congruent to the segment LM. We can also say the length is equal because it is. JK is equal to LM. Fabulous, because 5 equals 5, right? Easy, peasy, lemon, squeezy. We only have 2 more examples and we are done. All right, here's another example, okay? A lot of times when you guys see words, you get all freaked out on me, act really weird. Draw a picture, okay? Let's look at this first sentence. It tells us a lot. It says M is between L and N. Well, if M is between, that means I'm going to let L be one endpoint and N be another. And I'm going to put M somewhere in between those two, okay? Because now M is between L and N. We're going to use segment addition postulate to find LM and MN. So LM is 2x plus 4. And MN is 3x plus 3. The entire length of LN, is 22, okay? So using segment addition, we're going to take this segment and we're going to add this segment and we're going to set it equal to the entire thing. So 2x plus 4 plus 3x plus 3 is equal to 22. Now we have like terms, 2x and 3x. We add those together, we get 5x. We also have 4 and 3. We add those together, we get 7. That equals 22. Now we just have a 2-step. Subtract 7 from both sides. 5x equals 15. Divide by 5. X is equal to 3. Fantastic. All right, now we're going to look at another example. J is between H and K, okay? Very similar to the what we just saw. So I know H and K are my endpoints, and J somewhere in there, right? We're going to use segment addition to find. Oh, you know what I didn't do? I didn't plug it back in. Oh my gosh, I got to go back, guys. Because guess what? We found what X was, and I was like, hey, I'm fine with that. But what do I need to know? I need to find the length of LM and the length of MN. So we're going to plug that 3 back in. Oh my goodness. So LM is equal to 2 times 3 plus 4. Well, 2 times 3 is 6 plus 4 is 10. Well, if I know that LM is 10, and this whole thing is 22, I can subtract. I can say 22 minus 10 is equal to 12. Or I can plug it back into MN. Choices, man. That's why I like math. Math is all about some choices, right? You still get the same value of that. Now let's plug it in. 3 times 3 is 9. And 9 plus 3 is 12. Ding, ding, ding. I was right. So there's 2 ways to go about it once you have that first segment, as long as you did your math right. All right. So now back to where I was, okay? What I want you to do is pause the video and try to solve it on your own. See if you can do it, okay? And I'm going to keep going. So HJ is 5x minus 3, and JK is 8x minus 9, and the entire thing is enormous. It's 131, right? So now we can set up an equation by adding the segments together. Be careful about those negative signs or minus signs. I don't want you to lose those, okay? All right, once we write the equation down, the equation down, we just combine like terms. 5x and 8x are those like terms. 5 plus 8 is 13. Then I have negative 3 and negative 9. Negative 3 minus 9 is negative 12 equals 131. I'm going to add 12 to both sides. And 13x is equal to 143. And divide by 13. And I get x is equal to 11. Now, since I just made a mistake and I realized, oh my gosh, I got to plug it back in because I need to know what HJ and JK equal. So HJ is 5 times 11 minus 3. 5 times 11, 55, minus 3 is 52. Okay? Since these numbers are a little bigger, but you can totally subtract, right? I know the whole thing is 131. I know that this portion is 52. Well, then I get out my dusty little calculator, and I'm like, 131 minus 52 is 79. Also, if I want to plug it in, because I might think that's cool, 8 times 11 is 88 minus 9 is 79. I still get there. Same answer. Okay? But it's really important that we answer questions, okay? And read the whole thing. And ask questions if we don't understand what we're reading, because that is really important. All right, so hopefully if you guys had any problems with this or you're confused about anything in the book, just send me a Schoology message. I have the app, and I will do my very best to answer your questions and help you. And we'll go over all of this and yesterday's homework on Friday. So make sure you bring it with you, because I'm not taking any late notes. All right, here's your assignment. Assignment number 3, pages 12 to 13. Do problems 1 through 14, then 16 through 30. So it's really 1 to 30, but not 15. You do not need to do number 15. All right, and I hope you guys have an awesome day, and I will see you tomorrow. Bye.